Students, so here we will discuss solubility product. Students, they are salts which either get completely dissolved in water or they are insoluble in water. But there are certain salt, students, which gets dissolved in water but to a little extent. So those salts are known as the sparingly soluble salt. Let's take an example of AgCl. Now, so students, silver chloride, it's this salt when it has been dissolved in water, added to water, only some part of it gets dissolved in water and rest remain undissolved. But whatever salt is being dissolved, student, it gets ionized, right? Or we can say that their ionic equilibrium will be adjusted, right? So let's take an example of AgCl. Now we have taken AgCl. This is sparingly soluble salt, means less amount of it is dissolved. Right? So when AgCl is in solid state, it has been added into water, a part of it will get dissolved, and whatever part is getting dissolved, it will get ionized, right? Ag plus and Cl negative. So what they say, it will be in the ionic equilibrium. Either you will write this complete reaction or you can start the reaction from here also. Now student, from law of chemical equilibrium, we can write here K, that will be Ag positive, molar concentration of Ag positive, Cl negative upon molar concentration of AgCl. Now student, here these molar concentration, right, or these terms, we have to raise to the power the stoichiometric coefficient, whatever is written here. That means one molecule of AgCl, how much ion it is going to give. So if it is here, one molecule of AgCl is giving only one Ag plus and one Cl negative. So here we will write it in this way: K, this is Ag plus and this is Cl negative, and this will be known as student Ksp equals to Ag plus Cl negative. So this Ksp, student, is known as the solubility product, right student? So Ksp, this is student known as solubility product. And what is solubility product, student? At a particular temperature or at a given temperature, the product of the molar concentration of the ions which will be formed by one molecule of the electrolyte, right, when its saturated solution will be formed. So what is Ksp, student? At a particular temperature, for the saturated solution of an electrolyte of a sparingly soluble salt, right, it is the product of the molar concentration of the ions that will be formed for the per molecule, right, of an electrolyte, right? So if an electrolyte gives of its one molecule, if it gives two ions, so here it will be the product of the two ions only, right student? So this is the Ksp, and for that a particular temperature will be specified, and definitely the solution should be saturated one. So here you can see, student, the Ksp for the calcium for the Ca3PO4 whole twice. Student, here we get for each calcium phosphate molecule, we get 3 moles of calcium ion and 2 moles of phosphate ion. So the Ksp will be equal to the product of the molar concentration of calcium ion raised to the power of 3. In the same way, PO4 molar concentration raised to the power of 2, right students? So in this way you have to practice how to find out the KSP or write an expression for the sparingly soluble salt. Good morning students. Today we will discuss the numericals based on the solubility product. Hope so you must have gone through the solubility product and got this concept of it. So what is the solubility product? It is the product of the molar concentration of the ions which are formed from the saturated solution of sparingly soluble salt at a particular temperature by 1 mole of it. Right? How many ions are being formed from the 1 mole of a sparingly soluble salt at a particular temperature from its saturated solution. Right? It is KSP, and the KSP value will definitely change when the temperature will be changing. Right? And the solution has to be a student saturated solution. Now just have a look on the numerical here. The solubility of AgCl in water at 25 degrees Celsius is found to be 1.06 into 10 raised to power minus 5 moles per liter. Student, solubility, it is the amount of the solute which will be dissolved in grams in per liter of the solution. So, the solubility of this salt is given to us. And we have to find student KSP, that is the solubility product of AgCl at this temperature. So first of all student, we will write down the expression for AgCl. Right? So the first step will be to write down the equation for the AgCl ionic equilibrium. It will be student Ag plus Cl negative. Right? From this equation, it is clear that 1 mole of AgCl is giving 1 mole of Ag plus ion and 1 mole of Cl negative ion. Right? So, if it is 1.06 into 10 raised to power minus 5 mole will be dissolved in per liter of solution student, then this has to be 1.06 into 10 raised to power minus 5 mole in per liter of solution, and this one also 1.06 into 10 raised to power minus 5 moles per liter in the solution. Now student, we will write down the KSP. The KSP expression will be molar product of the molar concentration of silver ion and that of the chloride ion. You will put the here molar concentration, that is what is molar concentration, moles per unit volume. It is 1.06. So you will write down here 1.06 into 10 raised to power minus 5. Here also it is 1.06 into 10 raised to power minus 5 student. Right? So here KSP will be equal to 1.06 square into 10 raised to power minus 10. Right? So get this 1.06. You can get the square also directly, or you can get it multiplied also here. So here we are getting it to be, it is coming to KSP will be equal to 1.1236 into 10 raised to power minus 10, or you can drop down your answer to be at 1.1 into 10 raised to power minus 10. Also the last line is visible. Yes, it is. That is KSP will be equal to 1.1 into 10 raised to power minus 10. It will have no unit student. So it is solubility product of AgCl at this particular temperature, that is at 25 degrees Celsius. It is 1.1 into 10 raised to power minus 10. The next numerical, it is the solubility product for silver chloride is 1.2 into 10 is to power minus 10 at 298 Kelvin. Calculate the solubility of AgCl at 298 Kelvin. So here student, KSP is given to us, that is solubility product of the salt is given to us, and we have to find out the solubility. Now for that, we will first assume the solubility of AgCl to be S, or you can take any other letter also, but since the solubility starts with S, so we are preferring it to be smallest only. So let the solubility of AgCl at 298 Kelvin to be smallest. That means S moles per liter. S moles per liter, right? So now we will write down the next equation, that is the expression for the dissociation of AgCl. So we are getting here Ag plus and Cl negative, ions will be formed that coincide in active state. So AgCl, it is 1 mole here, it is 1 mole of Ag plus and 1 mole of Cl negative. So if it is S moles of AgCl is getting dissolved per liter, that time S mole of it, that means of, let it be smallest, S moles of Ag plus and S moles of Cl negative will be dissolved per liter of the solution. Now we will write down the expression for KSP. It is product of Ag plus and Cl minus. So we will write here KSP is student given to us. It is how much? It is 1.2 into 10 raised to power minus 10 equals to, and Ag plus, it is smallest, and this one is also smallest. So we are getting it as S square, taken in this way. So S square equals to 1.2 into 10 raised to power minus 10. So S will be, that is the solubility will be equal to students 1.2 into 10 raised to power minus 10, right? So this is the formula for the, or we can get the expression, we can calculate out student solubility. S equals to under root 1.2 into 10 raised to power minus 10. So when you will solve it out student, we will get S equals to, here it will come S equals to be 0 point something, so it is coming here 1 into 10 raised to power minus 5 moles per liter, right? So solubility student will be here 1.1 into 10 raised to power minus 5. Since the board is not getting clear, I'm yes, so the answer will be 1.1 into 10 raised to power minus 5 moles per liter. Right? So this will be the solubility. So students, you can get the numerical. Either you have to find out the KSP or you have to find out the solubility. Right? So one more thing is there. We have got the ionic product of a salt and we have got the solubility product of a salt. So how we are going to distinguish between the two? The students, the ionic product of a salt, right, it is at any concentration. It is the product of the molar concentration of the ions, right, given by the 1 mole of a particular salt, and that is at any concentration. That means the solution is not to be a saturated. Whereas for the KSP, that is solubility product, the salt has to be in a saturated state, right? And second difference, student, is the temperature. So KSP gets affected by the temperature, right? The solubility product will have a definite or a fixed value at a particular temperature, whereas ionic product is not doesn't have a particular value at a particular temperature, right? So just point out the difference between the KSP and the ionic product and get this thing noted down.